If you think questions about states of matter are easy, then think again. Just 9% of all entries on the 2023 paper got between 5 to 6 marks on this 6-mark question about states of matter. Now, I'm going to tell you today how you can avoid losing marks on states of matter question and how to match the mark scheme as closely as possible to maximize the amount of marks you get. Now, first things first, drawing particle diagrams is important, and don't fall into the trap of making liquid particles far apart. The particles should be touching, but there'll be tiny gaps between them because they're in a random order. And all particles you draw should be the same size. Draw them nice and big is my top tip. Now, sometimes in questions, they'll refer to something called kinetic theory. Now, kinetic theory is basically using the idea of particles to explain different properties of solids, liquids, and gases. So all this stuff involving particles, the official name for it is kinetic theory. Now, what I'll show you today is different properties you can use this to explain. Now, first things first, we're going to talk about states of matter changing today. We should know that solids to liquids is called melting, liquids to gas is evaporating, and the opposite processes are freezing for liquid to solid and condensing from a gas to a liquid. So let's use this idea of kinetic theory to help explain a few of these properties. So first one, this was in the question 2023, was how are the particles arranged? Now, whenever a question asks you about arrangement of particles, what it's talking about is there a pattern in their arrangement? So like in a classroom, in rows or in random distribution, gas and liquid, there is no pattern. They're all higgledy-jiggledy. Solid particles, they're arranged in a regular pattern. So you could say rows here or columns, but it is much better to talk about them being arranged in a regular pattern like you see in the diagram. The next thing we're going to talk about, and this was in the 2023 question as well, is their movement. So gas particles are the easiest ones to describe. They move freely at a range of speeds. So they do usually move faster than liquid, but some of them move slowly. They're a range of speeds and they're in a random direction. Liquid particles move freely. They kind of switch over places. They move pretty freely. Solid particles do move. Don't fall into the trap of saying they don't move, but they don't move very far. They just vibrate, and the really good phrase to learn is they vibrate about fixed positions. All that means is that they vibrate and they don't move anywhere, but they just go back and forth. So particles vibrate about a fixed position. So that's about movement. Now, whenever you're talking about these states of matter changing, then how do you talk about their movement changing? Well, you'd say they move faster, or they stop vibrating and start moving freely. Third thing we're going to talk about is spacing, so the spacing between particles. So in a solid, there is very little space between particles. In a liquid, if you look at the diagram, there's little space between particles as well, a little bit more, but still not much at all. And in a gas, there is lots of space between particles. So this could be used to explain things like density, and another property we'll come on to in a second. Now, for a solid, we need to know, and a liquid and a gas, are they compressible? Now, compressibility, an example would be if you put them inside a sealed syringe and you push down really hard on them, which ones would compress? A gas would, but a solid and liquid wouldn't. Now, the reason for that is due to the space between the particles. So what you'd say then is that there's little space, solid and liquids, they're not compressible, and that also means that they have a high density. There is lots of matter in the same place, whereas with a gas, there's very low density. So highest with a solid, a little bit less high with a liquid, and then gas is a low density. Now, talking about the particles and their movement helps explain why liquids flow and why a gas fills a container, whereas a solid does neither. So that's another example of linking the idea of particles to a properties of a solid, liquid, or gas. Next, let's talk about changes of state. So in any change of state, liquids to solids, solids to gases, etc., mass is conserved. You don't lose mass. Okay, so it's the same before and after a change of state. Now, one thing we could talk about when we talk about change of state is the idea of internal energy. Now, internal energy means the energy contained within the particles of a substance, and it's made up of kinetic and potential energy. Now, we should be quite familiar with the word kinetic energy for our energy stores. Kinetic energy refers to the amount of motion or movement or the speed of the particles. So if that increases, the kinetic energy increases. Potential energy is the one you're more likely to forget, which is all about the position of particles. So if they're further apart, the potential energy will increase. Let me show you what I mean with an example. So let's say we had a beaker full of ice and we have a thermometer in there, and over a period of time we apply some heat to the ice so we can monitor its temperature. Now if I was to monitor its temperature over time and plot it on a graph, we can have a look at what happens to the temperature and figure out a few different things about the substance. So initially the temperature will increase, which is what you might expect. Now that's because the particles are vibrating more. Then it melts at about 0 degrees for ice. Then it increases in temperature again when it's a liquid. Then about 100 degrees, it's going to evaporate into steam. Now, we're going to look at what happens in each stage. So the first stage, like I mentioned, is the particles are vibrating faster. That's when its kinetic energy is increasing, hence its temperature goes up. That's when it's a solid. Next, when it's a liquid, they're not vibrating, but they're moving faster. So the particles are moving faster, meaning the kinetic energy goes up. And as a gas, it's the same thing again. The particles move faster. So let's have a look more interestingly at what happens at these places where it goes horizontally. There's no increase in temperature. Now that's called the melting point, which is 0 for water, and the boiling point, which is 100 degrees for water as well. Now what happens there is that it doesn't vibrate more. Okay, the particles do not vibrate more because the temperature is constant, so they cannot be vibrating more. So what's happening there actually is that instead of the kinetic energy changing, the potential energy is changing. So the particles are becoming further apart, which means the potential energy goes up. Same as for a liquid to a gas, the particles are becoming further apart, so the potential energy increases. So what's happening at that point then? Where's the extra energy going? So at the melting and boiling points, energy is used to break the forces of attraction between particles. Now you could say bonds between particles here as well, that's fine, but forces of attraction is a good phrase to learn in mark schemes. So the idea is then there's no energy left over to increase the temperature. Now when we are talking about force of attraction, this is one other thing we could add to our list from earlier, which is that solids have a high force of attraction, liquids have a low force of attraction, and gases have none because the particles are not connected at all. So you can add that to the list from earlier. Okay, the last thing we're going to talk about today is something called latent heat. So let me give you an example. You've got a kettle full of water, you put it on a balance, and latent heat allows you to figure out basically how much energy you need to change its state. So there's an equation in your equation sheet, which is E equals m times L. Now L is latent heat, E is energy, m is mass. So to define it, we can say that latent heat is the energy required to change the state of 1 kilogram of a substance. So in this instance, 1 kilogram of water becoming steam. Now we'd measure the mass using a balance, and the energy supplied we'd find out from the power rating of the kettle. Now, one thing that catches people out is that there's two types of latent heat. One's called latent heat of fusion, which is from a solid to a liquid, and one's called latent heat of vaporization, which is liquid to a gas. Just keep your eye on the fact vaporization kind of sounds like evaporate, so liquid to a gas makes sense. So make sure you get full marks in this question if it comes up again.